So, when you hear the name Einstein, what's the first thing that pops into your head? Is it E equals mc squared? That crazy hair? Or maybe the whole mind-bending idea of relativity? You know, for a guy that famous, it's actually pretty tough to nail down his single greatest achievement. So let's dig in, because the answer tells a really fascinating story about how science and history decides what actually matters.
And right there, that brings us to the central puzzle we're tackling today. How do you measure greatness? Is it the work that completely rewrites our understanding of the universe itself? Or is it the one that gets you the world's most famous award? Because for Albert Einstein, believe it or not, those are two totally different things.
Here's the mystery in a nutshell. On one side, you've got the theory of relativity. What everyone agrees is his masterpiece, the thing that redefined space and time. But then, on the other side, his 1921 Nobel Prize in Physics? Yeah, it wasn't for relativity. It was for his work on something called the photoelectric effect. That's the puzzle we're going to piece together.
So our investigation has to start with the first big contender for his greatest accomplishment. This unbelievable creative explosion that happened in a single year. A year that historians now call his annus mirabilis, his miracle year. The year is 1905. And you got to picture this. Einstein is only 26 years old. He's not some celebrated professor, he's a patent clerk in Switzerland. His official title is Technical Expert Third Class. And in his spare time, literally hiding his work from his boss in a desk drawer, he publishes a few papers that are about to detonate the entire world of physics. I mean, just look at the sheer scale of this. In a few months, he gives us the first real proof that atoms are real things by explaining why little particles dance around in water. He introduces special relativity. He drops the most famous equation in history, E is mc squared, showing that mass and energy are basically the same stuff. And he explains the photoelectric effect. Any one of these would have made him a legend for life. He did all four in 1 year.
Okay, let's zoom in on that last one, the photoelectric effect. See, at the time, everyone knew light was a wave, period. But Einstein came along with this really radical idea. He said, what if light also acts like it's made of tiny, individual bullets of energy? We call them photons now. This wasn't just some small tweak. It was one of the founding pillars of a whole new and very weird field of physics, quantum mechanics.
And this quote from one of his old university professors who was totally fed up with him, it just tells you everything you need to know. It shows you the kind of mind that could pull this off. It wasn't just about being smart. It was this stubborn, absolute refusal to just accept what he was told was true that let him see a reality that nobody else could even imagine. Okay, so if 1905 was the breathtaking sprint, let's turn to our second contender. This was the decade-long intellectual marathon. This was the slow, difficult, grinding journey to his absolute masterwork, the general theory of relativity. To really get how huge this was, you have to appreciate what he was replacing. For more than 200 years, the universe ran on Newton's laws. Gravity was some mysterious, invisible force that just pulled things. It was fact. And Einstein basically said, nope. He said gravity isn't a force at all. It's what happens when mass and energy literally bend and warp the fabric of space and time. Planets aren't being pulled by the sun. They're just following the curves that the sun's enormous mass creates in space-time.
So how on earth did he come up with that? Well, it started with what he called his happiest thought. Imagine you're in an elevator, a sealed box with no windows. You drop your keys, they fall to the floor. Now, are you sitting on Earth, feeling gravity? Or are you out in deep space, inside a rocket that's accelerating up? His incredible insight, what he called the principle of equivalence, was that there is absolutely no experiment you could do inside that box to tell the difference. And that was the key that connected gravity and acceleration.
And the theory that grew from that one simple idea? It was unbelievably powerful. It made these wild predictions that would take decades, even a whole century to prove. It perfectly explained this tiny little wobble in Mercury's orbit that had been driving astronomers crazy. It said that a star's light would literally bend as it passed the sun. It predicted black holes, objects so dense that light itself can't escape. And it predicted that huge things colliding in space would send out ripples in space-time itself. Which, of course, brings us right back to our central mystery. If general relativity was this incredible, universe-changing masterpiece, why did the Nobel Committee give him the prize for the photoelectric effect instead? Well, bottom line, the committee got cold feet. Back in 1921, general relativity was just too weird, it was too radical. It didn't just add to the old physics, it threw out the entire rule book about space and time being fixed and absolute.
The main proof they had that bending of light was brand new and people were still arguing about it. Honestly, its ideas were so huge that a lot of the committee probably just didn't fully get it yet. The photoelectric effect, on the other hand, was still revolutionary, but it was a much, much safer bet.
So, with that mystery out of the way, we can finally step back and deliver a verdict on Einstein's true masterpiece and what his ultimate legacy really is.
So what's the final call? Look, the miracle year of 1905 absolutely changed physics forever. But history and physicists today have made a pretty clear judgment. General relativity is his single greatest achievement. It's his magnum opus. It wasn't a sudden flash of insight. It was the result of a decade of pure, relentless thinking that fundamentally altered our conception of reality itself.
And this timeline just drives home how incredibly far ahead of his time he was. The bending of starlight gets confirmed in 1919 and he becomes a global superstar overnight. But his prediction about gravitational waves, that was so out there, so beyond the technology of his day, that it took us a full century and one of the most amazing experiments in human history, LIGO, to finally detect them in 2015, proving him right yet again. It's just mind-boggling.
In the end, Einstein's true legacy isn't just one theory or one equation. It was a complete shift in how we see the universe. He single-handedly dragged physics from the neat, tidy, clockwork world of Isaac Newton into our modern cosmos, where space and time are not separate things at all, but are tangled together, all relative, dynamic, and interconnected. And that leaves us with one last, just awe-inspiring thought. Einstein's story isn't only about physics. It's about the incredible power of human curiosity. And it leaves us with a pretty powerful question. What happens when one person's imagination, just pure thought, turns out to be more real than reality itself?